Hey folks, this is Nick from First Coast Math Clinic. In this video, we're going to get into how do we find the area of parallelograms, rectangles, and squares. So those are the three shapes we're going to look at: parallelograms, rectangles, and squares. We're not going to get too much into the properties of the three shapes and the relationship between the three. I'm going to make a separate video a little bit later on about the properties and relationships of the three. I'm just going to focus on finding the area of parallelograms, rectangles, and squares. All right. Before we get into any of this, make sure you've liked, comment. So let's start with rectangles. Now, basic definition of a rectangle is it's a parallelogram with four 90-degree angles. So we've got our four 90-degree angles here, and we've got our length and our width. And if we want to find the area, so we know that the area is just the amount of space inside our shape. Our area is going to be equal to the length times the width. So if our length in this example is, let's say, 9 inches, and the width is 5 inches, then our area we could find by multiplying 9 inches times 5 inches. We have to include the units, inches and inches, and our area is going to be 45 inches squared. So we're going to square our units. Okay. All right, let's get into a couple more examples. So let's say we've got something like this. So we've got our rectangle here, got our four 90-degree angles, and we've got maybe 12 centimeters and X centimeters here, but we know that our area is equal to 60 centimeters squared. So how would we figure this out, right? So now we're looking for our width. We want to figure out this length, okay? Well, we can use our area formula. Area equals length times width. We know our length is this 12, right? So that's going to be our length. And we know our area is 60 centimeters squared. So we could have 60 centimeters squared equals 12 centimeters times X centimeters. We want to get the X centimeters by itself. So let's divide by 12 centimeters and 12 centimeters. 12 centimeters and 12 centimeters cancels out on the right, and we get X equals our centimeters and centimeters cancels out, so we're left with just a single unit of centimeters. 60 divided by 12 is going to give us 5 centimeters, so X equals 5 centimeters. So our width here is going to be 5 to get an area of 60. All right, let's do one more example. So we've got a rectangle here, got our four right angles, and for this, let's say that our dimensions, put some variables in with our dimensions as well. So let's say we've got maybe 3x and 4x for our length and our width, and our area is 48 inches squared. So we again want to use our formula. Area equals length times width. We know our area is 48. We know our length is 3x. So this is going to be our length. This 4x is going to be our width, so let's substitute those values in. And let's just go over how we're going to deal with multiplying the 3x and the 4x. So we've got 3x times 4x. 48 equals 12. Now we're multiplying x times x. Remember our powers here are x to the first times x to the first. So this is going to give us x to the second. If we multiply the bases, we have to add the exponents. So we want to get the x by itself. So let's start by dividing and dividing. So we're going to divide by 12, divide by 12. (48) divided by 12 gives us 4. So we get 4 equals x squared. Now I'm going to take the square root and square root. Square root of 4 is going to give us positive 2 and negative 2. We're dealing with a length here. I only want that positive answer, so I'll keep my positive answer 2. We can get rid of that negative answer. So our answer is going to be positive 2. Now I want to find the actual length of these sides, right? So if I want to find my my length, right, I could take this 2, put it in for x here and here. So I'm going to have 3 times 2, and this length is going to be 6. Our units are inches. And if I want to find my width, I'm going to take the 2, put it in for x. I'm going to have 4 times 2. And my width is going to be 8 inches. And if we double check, well, 6 times 8 is going to give me back that area of 48 inches squared. So my area checks. Okay? All right, let's get into parallelograms. Okay, so we've got a parallelogram here, and the main property of a parallelogram is that it's a quadrilateral, so a closed four-sided figure where opposite sides are parallel. All right, we're going to talk more about the properties of parallelograms when we get into it, but that's kind of our main definition of a parallelogram, right? A quadrilateral where our opposite sides are parallel. So let's think a little bit more about this, right? And compare it back to what we said about a rectangle, right? We've got this area here. Just this. If I kind of just draw this here, this height in here, and copy this over. All right, well, we got a triangle right here. Okay. Well, where else do we see this figure, this triangle, right? Well, I see that triangle. This triangle would match up right here. So I could redraw that triangle in red right here outside the parallelogram. Now let's think about what we did by moving this red shape, this red triangle over here, okay? What did we create? Well, if I just trace this over in black, we basically just have a rectangle, right? So we could use a similar formula to find the area of a parallelogram. We've got our length and our width. So to find our area, we know we could just multiply the length and the width together. But if it's a parallelogram, we're not going to call them length and width. We're going to call the length our base, and we're going to call the width the height. So this is going to be base times height. And the main relationship between base and height is our base has to be perpendicular. So this upside down T is our perpendicular symbol, has to be perpendicular to our height. So typically when we're going to draw this in, our height is going to be like inside of our parallelogram. So let me kind of get rid of this and show you how it's really going to be labeled. So our height is typically going to look something like this, and it's going to be the perpendicular distance between our two bases. So if our height is right here, it's going to be perpendicular to our two bases. I'll do this in green. So we've got a base here and a base here. So our bases are going to be our bases are going to be parallel to each other. So our height's in red and our bases are in green. And if we want to find our area, we've got to multiply our base times our height. So let's say that our base is 8 inches and our height is 6 inches. Then our area is going to be 8 inches times 6 inches. So our area is going to be 48 inches squared. All right. All right, let's get into a couple more examples where we find the area or work with the area formula for a parallelogram. So let's say this is our second example, our parallelogram for our second example. And let's say that for this example, our base here is going to be 15. We'll draw in the height here. So it's going to be parallel to the two bases. That's going to be h, our height. And we know our area is going to be 90. So we want to find the height in this example. So how do we find the height here in this example? Well, we know our area formula is base times height. Area is 90. Let's put some labels of this too. So area will be 90 inches squared and then inches. So we'll have 90 inches squared equals 15 inches times h. Let's divide by 15 inches. 15 inches, and then our height, 15 inches, and inches cancels out. We're going to get 6 inches as our height here. Let's do one more example. You sketch this in up here. So let's say for this parallelogram, we know that this side is 5. We know that we've got our height here, which is perpendicular to the bases. We know that our height here is 4. And we know that this distance right here, let me do a different color for this. This distance right here is 7. We want to find our area. So we know our height. We need to figure out the rest of this base. This entire length is our base. We need to figure out this length right here. That's going to be our x. So how will we do that? Well, we notice that right here, we've got 5, we've got 4, and we've got x. So we've got a right triangle here, all right? And our height creates a perpendicular angle, a right angle with the base. So we've got a right angle, a right triangle here. So we could use Pythagorean theorem to figure out that x and then add it to 7 to get the total length of that base. So let's do that. Let's use Pythagorean's theorem to figure out x and then add it to 7 to get that total length. So h is the hypotenuse, or 5 is the hypotenuse, so we're going to have 5 squared equals the sum of the square of the legs, so x squared plus 4 squared. I have a separate video on Pythagorean's theorem if you want to check that out. There's a link that's coming up right now. You guys can review that as well. So let's solve this. 5 squared is 25 equals x squared plus 16. Let's subtract 16. Subtract 16. We get 9 equals x squared. I take the square root and square root. Since it's a length, I want just the positive answer, so x is going to be 3. So this length is 3. So this entire length here is going to be 3 plus 7, or 10. So we know our height is 4, our base is 10, so now we could find our area by multiplying our height of 4, our base of 10, and getting an area of 40. We'll put in units squared because our units are always going to be squared. Okay? All right, let's finish up by finding the area of squares. All right, so a square is the combination of a rectangle and a rhombus. We talked a little bit about a rectangle. We haven't talked much about a rhombus. I'm going to make a separate video on a rhombus and the properties of it later on. But a rectangle has 4 right angles. A rhombus has 4 congruent sides. And when we put those together, 4 right angles, 4 congruent sides, we get a square. Now, to find the area of a square, we can just call each side S, because all of our sides are the same. And if we're multiplying side times side, or S times S, so side times side, this is just going to be side to the second power, side squared. So let's say that our side length is 4 inches, then our area here is going to be 4 inches squared. So our area of this figure is going to be 16 inches squared. Let's do a couple more examples with area of squares. Let's say we've got a square here. Again, 4 right angles, 4 congruent sides. Let's say we don't know our side length, so we'll just call our side length X, but we know the area is 144 feet squared. So how are we going to figure out X? Well, we know our area is side squared, or just X squared in this case. Area is 144, so we've got 144 feet squared equals X squared. Let's undo squaring and take the square root and square root. Well, what's the square root of 144? Square root of 144 is positive and negative 12. I just want positive 12, so let's keep the positive answer. So my side length is positive 12 feet and 12 feet. So each side length here is going to be 12 feet. Let's do one more example. So let's say we've got a square up here. And in this example, let's say our side length is 5x, and we know our area is 225 inches squared. We want to find x, and then see if we could figure out our side length as well. So we know that our area is equal to our side squared. So our side in this case is that 5x. The area in this case is the 225 inches squared. So we're going to have, we'll write it down here, 225 inches squared equals 5x squared. I want to put the 5x squared in parentheses because I'm squaring the 5 and the x as well. If I just wrote it like this, then I'm just squaring the x, not the 5. So I want to make sure I put it in parentheses. So my next step, I'm going to get 225 inches squared equals 25x squared. Square the 5, square the x. Let's divide by 25 and 25. 25 cancels out on the right. I get x squared equals 25 divided by, 225 divided by 25 is going to give us 9 inches squared. I want to take the square root. I'm going to write this a little neater, so just give me 1 second. So 9 inches squared equals x squared. So let's take the square root, and then the square root of 9 inches squared is just going to give us 3 inches. So our value for x is 3 inches. And then if we want to figure out the actual side length, right, we have 5x, so we get a 5 times 3, giving us 15 inches and 15 inches for each side, okay? All right, so this video was on how to find the area of parallelograms, rectangles, and squares. I hope this video helped you guys out a little bit. If you like this video, leave a like, comment, and subscribe. This is Nick from First Coast Math Clinic.